This video is on image formation by the eye, specifically focusing on vision deficiencies. So the first thing that I'm going to be going over is the basic anatomy of the eye. As you can see here from this picture, there are several key structures that are helpful in helping the eye produce images, but I'm only going to be going over a few as I feel that they are the most relevant to this video. These include the retina, the iris, the lens, it's not labeled, but the cornea, and the pupil. So, how do we see? We learn that objects are visible because of the light that gets reflected from them. This reflected light then enters our eyes and we are able to see that object, in this case, a soccer ball. But what happens inside our eye when the light rays enter it? What helps us see the world around us? Factoring in the anatomy here, the outer layer of the eye is called the cornea, and it is a curved white transparent layer. It allows light to pass through. It also serves to refract or bend that light coming through it. Most of the refraction in our eye is actually thanks to the cornea. Another function is it serves to protect the inner eye from our surroundings. Behind the cornea lies the iris, as shown here in blue. It determines the color of our eyes, such as if you have blue eyes or brown eyes. There is a small opening in the middle of the iris where light can enter called the pupil, as shown here. The iris acts as a shutter of a camera and controls the amount of light that can enter the eye by enlarging or shrinking, and thus adjusting the size of the pupil. This is why when you look directly at or near or are in a brightly lit environment, your pupil will shrink. The intensity of the light is too much for your eyes to bear, and shrinking the pupil will filter out unwanted light. On the other hand, the same happens in a darker environment. Your pupil will expand to catch more light. As light enters the pupil, it falls on the lens behind it, as shown here. Our eyes naturally have a convex lens. As we previously learned in class, a convex lens is one that is thicker in the middle and thinner on the edges. It is a converging lens that focuses all the light at one point. In a normal regular eye, such as this one, the point is somewhere on the back of the eye on a structure known as the retina, as shown here. The retina, again, is at the back of the eye and is the inner layer of the eyeball. It contains many nerve and photoreceptor cells called cones, which are sensitive to bright light, and rods, which are sensitive to dim light. From there, the image is then transferred to the brain through the optic nerve as an electrical signal. One thing that I want to talk about a little bit more is the role of the lens. The converging lens that we have also plays a part in refracting a little bit of light, but more importantly, it makes sure that the images are formed on the retina only. By changing its shape, the lens controls the direction of propagation of light. The ability of the lens to change its focal length is called accommodation. I'm not going to go super in depth into the physics behind the eye, as this is covered in another video topic, but I'm going to be focusing more on some common vision deficiencies instead. So some of us are not able to see the objects closer to us, while others are unable to see objects farther away. Why is that? We're going to be going over two common vision deficiencies that are the cause for this problem, which is myopia, or nearsightedness, or hyperopia, farsightedness. Another really common vision deficiency is called astigmatism, when there is a problem in the curvature of your eye. But first, let's go over myopia, or nearsightedness. It is one of the most common vision deficiencies. It's a condition of the eye in which the nearby objects can be seen clearly, but distant objects, here, with a spoon, they appear very blurry. How does the light propagate inside a myopic eye? Well, the light from the nearer objects travels in the usual way, and it gets focused on the retina. But in distant objects, the light rays from that object, spoon here, for example, are coming in almost parallel to each other. And when the light rays enter the eye, they get converged in front of the retina, as shown here in front of the retina, instead of on the retina. This is the cause for the blurry image of the spoon. But what causes the light to converge in front of the retina? This is because of the larger size of the eyeball. Due to the elongated shape of the eye, the distance between the lens and the retina is greater than usual, and this causes the spoon image that we saw before to form in front of the retina. One thing to note here is that the lens itself is still functioning completely normally. It does its job, but the image is formed at a different position because of the eye shape. In comparison to a normal eye, you can see that it is not as elongated and is rounder in shape. The rounder shape allows for the correct images to form on the retina. So how can we overcome this problem? Very simple. we can use lenses. In this case, we use a concave lens when we get our prescription glasses. Why a concave lens? Well, we know that a concave lens diverges light, and these divergent rays fall on the lens at an angle where they are able to refract and come together on the retina instead of in front of it. Another extremely common vision deficiency is called hyperopia, also known as farsightedness. Hyperopia is essentially the opposite of myopia, where distant objects appear very clear and objects closer to you appear very blurry. This is because the light is focused behind the retina, as you can see here, rather than on the retina. When you have hyperopia, when objects are closer than about 6 meters, the light rays start to come in parallel to each other, and they end up diverging and changing the focus of the image. This is actually when you go to the eye doctor, when you go to the eye doctor and they have you read off the chart is actually placed 6 meters from you. So just a little fun fact. The cause of hyperopia is the opposite of myopia, where instead of being elongated, the hyperopic eye is actually smaller and more compact than usual. The distance between the lens and the retina is smaller than it should be in a normal eye. As you can see here, the normal eye is not as compact, not as small, and again, the rounder image allows for images to correctly form on the retina. So, to correct this problem, it's very simple. Like myopia, it requires the use of a lens. However, the type of lens used in prescription glasses in hyperopia is a little different. We use a convex lens. Why a convex lens? The convex lens helps in focusing the light in the correct place and projecting the image correctly onto the retina. Let's take a look at the last deficiency, astigmatism. A little recap of the anatomy. We know that the cornea is a curved transparent outer layer which reflects most of the light entering the eye. Sometimes the curvature of the cornea is distorted, as you can see here in yellow, where it can become slightly elongated in the middle. This is an example of astigmatism. What happens when someone has astigmatism? With astigmatism, all the light is not focused at one point like it should be. In fact, it's focused at multiple points, as you can see here. Although this picture shows both points on the retina, this is not always the case. Sometimes the points can move around and they may or may not end up on the retina. As you can see here in this picture, they could be behind the retina or they could be in front of the retina. Astigmatism also results in objects being really blurry because you can't focus the image with your eyes. So this is just a little recap of what I just went over. The interesting thing about astigmatism, though, is that it can actually be paired with myopia and hyperopia, depending on whether your cornea is curved more steeply in one direction or the other. So this is obviously a problem, and how can we fix this? Well, it depends. There are several things that can be done to help. The first one, which is arguably the most simple, would be to use lenses. Depending on the curvature of your cornea and whether or not it is paired with myopia or hyperopia, you can actually use a concave or convex lens when you get glasses. Another thing that you can also do is have LASIK eye surgery, where they replace your cornea and you have a regular shape to see regular images. That's the end of my video. Thank you for watching, and I hope you enjoyed.